Well, hello again. We're going to start a new unit, and this unit is Trig Identities and Proofs. Yes, proofs, yay! And what I want you to do first of all is I want you to go download a file off of Edline. It's on your assignments page, and it's called your Properties of Trigonometric Functions Formula Sheet. And we are going to be using that formula sheet the next couple of weeks. And the ones that I'm going to look at today are reciprocal, Pythagorean, and quotient. So this document right here, you can go ahead and save to your computer, or you can print it out and have it. I'll give you a copy tomorrow in class. And we're only going to be using the top 3 of these today, but this is a 2-page document. And we're going to be investigating all of these equations and all of these formulas. So go ahead and grab that. Alright, what I would like to do first is I want to show you one of our Pythagorean identities. And we are going to start with a little picture. And this picture is going to be, if I just have this little triangle here, and I'm going to have x, and I'm going to have y, and I'm going to have r. And then the theta is the angle. We call that our reference angle. And if this is a right angle, then we have a Pythagorean theorem relationship here, and that is that x squared plus y squared is equal to r squared. Now, since r is positive and not 0, I can divide through by r squared to get the statement x squared over r squared plus y squared over r squared is equal to r squared over r squared, which of course is 1. This can be rewritten as x over r squared plus y over r squared is equal to 1. And from this picture, I can replace x over r with a trigonometric function. And of course, that's the cosine of the angle theta. And then y over r I can replace with another trigonometric function, and that is sine of theta. And this is usually written as cosine squared theta plus sine squared theta is equal to 1. And this is probably our most important. It's called a Pythagorean identity. And it's a formula that we're going to use a bunch. And you'll see on your formula chart, it's the very first thing under Pythagorean identity. We can, and we're going to in the next couple of weeks, we can manipulate this to get almost everything on this sheet, especially those next 2. But it's just a fact that we're going to use. Cosine squared of an angle plus sine squared of an angle is equal to 1. If you want to go grab a calculator right now and pick any angle you'd like, I don't know, and put it in degree mode and say 70 degrees. And if you wanted to ask your calculator for the cosine of like 70 degrees and you squared it, and you found the sine of 70 degrees and you squared that and you added those 2 values together, I promise you, you're going to get 1. This value, this works no matter what angle we're talking about. Okay, there's some other things on that sheet that we're going to look at, but I want to go through a couple of examples what you're going to have to do. And so what we're going to have to do today is we're going to start with an expression and we're going to transform it or simplify it into another expression. And we're going to do that using our Trig Identities formula chart. And so we're supposed to transform sine x times cotangent x to get cosine x. So what we're going to do is look at our chart to see if there's some kind of substitution we can make. And if you look at that chart, there is a substitution we can make for sine of x. And in sine of x, I'm sorry, not for sine of x, but for cotangent. Cotangent is equal to cosine over sine. Now, well, you guys already knew that, but we have it on our quotient there. So if cotangent is cosine over sine, then I can replace cotangent with, get my little pen here, blue, to cosine x over sine x. And since I have performed that replacement, I can put a sine x over 1 here, and that sine x cancels with that sine x, and we had simplified this to cosine x just like we were told to. We're heading into proofs. This isn't quite proofs yet. This is just simplifying, but we're heading into proofs. We're just practicing basically using the formula chart. Number 2, I'm going to transform sine of x times secant x times cotangent x to 1. Well, if you multiply things together to get 1, there better be a lot of canceling. If you look on your formula chart, secant x is 1 over cosine x. I'm going to put a 1 under that sine x as well. And cotangent, from the previous example, we saw that was cosine over sine. All right, let's see what happens here. As long as we're multiplying, you can cancel one thing from the top and one thing from the bottom. So those sines cancel, the cosines cancel, and I end up with 1 over 1, which is, of course, is 1, which is exactly what I was supposed to get. Okay, the next one is going to require some substitution. And this is cosine squared minus sine squared to 1 minus 2 sine squared. Now, we had before, at the beginning of the video, we said that cosine squared of an angle plus the sine squared of an angle is equal to 1. I can use that formula and rewrite this in terms of cosine squared. In other words, I could subtract sine squared from both sides and get a replacement for cosine squared, which means cosine squared is equal to 1 minus sine squared x. Now, why would I do that? Because I am told to transform this form into something that doesn't have a cosine in it at all. So I need to substitute for that cosine squared. So instead of that cosine squared, I'm going to write 1 minus sine squared. So we're going to write 1 minus sine squared x. That's a replacement for cosine squared, minus sine squared x. And let's see what happens here. These minus sine squared and look at there. Minus sine squared, that is 1 minus 2 sine squared of x, which is exactly what I wanted. Next page. Okay, now we're going to transform a 1 plus cosine a times 1 minus cosine a to sine squared. And here there's not a substitution for cosine to make, because it's not cosine squared. So let's try some algebra in this case. And of course, we know that this isn't just that times that and cosine times cosine. We are going to FOIL this, double distribute, whatever you want. But we are going to multiply all of this together here. We're going to make, oh, looky, look, it's a smiley face. See the little mouth and never mind. Okay, anyway, so if we FOIL this out, we get 1 minus cosine a plus cosine a minus cosine squared a. Those middle terms cancel and we get 1 minus cosine squared a, and we saw that before because cosine squared of an angle plus sine squared of an angle equals 1. We can subtract cosine squared from both sides and we can get a statement that says sine squared is equal to 1 minus cosine squared. So this equals sine squared, which is exactly what I wanted. This is just like magic. It's like Harry Potter. All right, let's see here. Let's do another one. We need to transform this side to that side. And here I've got, again, algebra to do. So I'm going to square this. And of course, we all know that this isn't just cosine squared minus secant squared. We have to FOIL this out. This means cosine m minus secant m times cosine m minus secant m. We can't just multiply the first times the first and the last times the last. Fix my cosine there. We have to FOIL this, double distribute, whatever. So we're going to get cosine squared m minus 2 secant m cosine m plus secant squared of m. So we did first times first, outer times outer, inner times inner, and last times last. Now let's see, we're trying to turn this into tangent squared minus sine squared. Let's look at this middle term here. Secant and cosine happen to be reciprocals of each other. So I have cosine squared m minus 2 times 1 over cosine m times cosine m over 1 plus secant squared m. So what happens here is those cosines cancel, and I'm left with cosine squared m minus 2 plus secant squared m. Now here it appears we're in trouble because we don't even have a tangent or a sine. But let's go back and look at this Pythagorean identity that has to do with tangent. And you might see in that Pythagorean identity that tangent squared plus 1 is equal to secant squared. So let's go take a look at what we have. We have, scroll down here, there's a 1 here and there's a secant squared, so we know that tangent squared, I realize that's not a 1, but it is a 2, you can pull a 1 out of that. Tangent squared plus 1 equals secant squared. So we know that tangent squared equals secant squared minus 1. So let's see how cool this can get. I'm going to write this as cosine squared m minus 1 plus secant squared m minus 1. Check that out. This minus 1 and that minus 1 make that minus 2. So here is your tangent squared. And the last one is cosine squared minus 1. And is that a negative sine squared? Remember, cosine squared plus sine squared equals 1. So if I subtract 1 from both sides and I bring the sine squared over here, what is cosine squared minus 1? Well, looky there. It's negative sine squared. So this becomes negative sine squared m. And then this is plus tangent squared m, which of course we can just write the tangent squared first. And this is tangent squared m minus sine squared of m. That one wasn't too easy. All right, let's take a look at one last example where we have two fractions together, and we're supposed to bring these together for cotangent. So here I have two fractions, and I'm going to bring these together, and you can make a common denominator if you'd like. I like to crisscross multiply. I've shown you this before. To crisscross multiply, we can do secant x times cosine x minus sine squared x. That's cosine times secant and sine times sine. I've cross multiplied all over cosine x times sine x. And let's see what happens in the top. In the top, secant times cosine, these are reciprocals because secant can be rewritten as 1 over cosine x times cosine x over 1 minus sine squared x. And this is all over cosine x sine x. And so on the top we get 1 minus sine squared, we've seen that before, over cosine x sine x. And what's 1 minus sine squared? That is cosine squared of x over cosine times sine. Now cosine squared means cosine times cosine, so I can cancel one of those cosines with this cosine, and I get cosine over sine, which happens to be cotangent, just like a miracle. There you go. I'll see you tomorrow.